We are Spectrum Center. We are going to have an initial introduction into the organization. Some of you may already be familiar with some of this information, but this is for attendees that are new to the organization. Also, we are going to then continue with the overview of the SpectrumE API, which is the SpectrumE feature that we're going to focus on today. We'll then highlight some use cases, in particular one for the Spectrum Authority of Brazil, Anatel. And then we're going to go into a demonstration of the API, and then we have opportunity for questions and answers. So this should take approximately an hour, including the questions and answers. So if you have want to have an idea how long everything should take, we should be done in about an hour. Okay, who we are, what we do. We are Spectrum Management Specialists. Spectrum Center is the unification of the former ATDI offices in the US, UK, and Brazil. And we focus our business on the resale of commercial off-the-shelf software for spectrum management. We sell it as a SaaS solution or a perpetual license solution. So SaaS meaning software as a service. So it can be purchased on a subscription basis, or it can be purchased as perpetual license product. That's a permanent license product. We do provide enterprise solutions based on modified off-the-shelf implementations of adapted versions of SpectrumE. That's quite common, especially when we work with large organizations, large regulatory organizations in particular. Usually there's a fair amount of adaptation that has to be done to adapt SpectrumE to meet this kind of a customer's needs. We also provide professional services such as consultancy, measurement drive testing, and development of custom software solutions for current and new customers in the spectrum regulation and commercial industries. Our representative offices are Spectrum Center, Inc., located in McLean, Virginia. We are the main product developer, product leader for the SpectrumE platform. We do, of course, receive contributions from our other offices, but the product is integrated in the U.S. and published in the U.S. We are an ITU member, as well as a member of the U.S. National Spectrum Consortium, and also we hold a GSA Schedule 70 contract for reselling our software products to the U.S. government. We also hold a DoD secret clearance. And we have a sister organization known as Spectrum Center LLC that focuses on providing professional services, engineering services to the U.S. federal government. Also holds a GSA PSS schedule, also holds security clearance, and is also located in the McLean, Virginia area. And we have an office in the UK. The office in the UK primarily focuses on sales efforts in the Eastern Hemisphere. And that's what we would, in the spectrum regulatory world, classify as ITU regions 1 and 3. Also a member of the ITU and a contributor, and based out of the United Kingdom. And we have an office in Brazil that specifically focuses on our customer in Brazil. We have several customers, but our principal customer, our largest customer is Anatel, the Spectrum Regulatory Authority of Brazil. The office in Brazil is based out of Brasilia. Past performance, we have over 31 customers in the federal government amongst 12 agencies. I've summarized a number of them here in the screen. So our products are pretty ubiquitous throughout the U.S. federal government. And we provide the software and in many cases as well as additional services to all these federal agencies. So they are longtime customers in many cases over a decade working with Spectrum Center. And we provide them spectrum engineering tools, spectrum management tools, and as I mentioned, consultancy services as well. And in outside the U.S., we have a good amount of business with several spectrum regulatory customers. These are spectrum or telecommunications authorities. We have several in the Latin American region, some of the biggest ones including Brazil, Colombia, Argentina, Mexico, Chile, and many more, and also several in the Caribbean. And we've been expanding, winning contracts in Israel as well as Myanmar. The Post and Telecommunications Department of Myanmar is one of our more recent customers. Most of these deliveries are implemented as modified off-the-shelf deliveries. So we take our Spectrum E system and the entire platform, and it's installed in the customer's local environment. In some cases, we also provide the IT infrastructure, or we partner with a local company to help us with the delivery of the necessary server infrastructure. In some cases, even do a little bit of build out to create a kind of a data center space to host the system. So that's fairly common in the deliveries for customers such as these. So what is Spectrum E? Many of you already know about this, but for customers that are new to interacting with us, we'll give a highlight of Spectrum E, an overview, you could say. So Spectrum E is a spectrum management web application. It's probably the first of its kind, as far as I know. Most spectrum management software systems were developed several years ago, decades ago, and our work is, a local a client server application, but where you have to actually install a client software. So that's, a little old-fashioned. A more modern approach is to have the software run off a web browser. So we kind of, our first attempt at making spectrum management systems, we made them in that way where a customer would have to install a local application at the client terminal. But today, very common for everyone just to run everything through a web browser, because it runs off a web browser. Obviously, doesn't mean it has to run online. It can run inside of an intranet, or can run offline, which we'll highlight in another part of the PowerPoint here. But it's composed of three principal modules that we resell. One is called e-licensing, and so that facilitates kind of a web portal that would allow operators to interact with spectrum management authorities or telecommunications authorities for the reception of license requests, for example, or equipment type approval, or the kinds of activities that a telecommunications regulator would be in charge of. And so there's the e-licensing module, then there's a technical analysis module. So this is all the engineering aspects of spectrum management, propagation analysis, interference analysis, etc. This is all contained in the technical analysis module for all the radio services, whether it's broadcast or mobile or cellular or maritime, aeronautical, satellite. It's all covered in the technical analysis module. And then we have what we call a remote monitoring or remote measurement module. So that module is designed to work with measurement equipment. We don't sell the measurement equipment. We work with several vendors that we've integrated our products with over several years. So those are all the main well-known vendors in the space, everyone from Roden Shores, TCI, and Ritsu, and so forth. We work with all of them. And so what we do is basically offer the ability for someone from the spectrum management side to launch measurement requests remotely to a monitoring device and then receive the results, rather than necessarily having to go out in the field to do that. So that's developed along ITU guidelines as well. And that's been kind of in demand for a while amongst regulatory authorities. The Spectrum E platform can be delivered in a diverse manner of options. So you have what we call the left-hand side here, you have the local host delivery. So that would be local to the customer's IT environment. So it can be in a local area network. Software can be installed on a server, and the client can connect through an intranet to operate the system. Can also be completely disconnected. You can run the software offline entirely right on your laptop like any other software application. And so, like I said, it doesn't require to be connected to the internet to operate. It just leverages that aspect. In the second case, this would be the cloud option. So that allows us to sell the software at different price points and to different customers as well, such as consultants and so forth that really just need to maybe only use the software for a specific period of time. They can leverage the subscription option, and in that case, they just get credentials to log in, and they get access to our cloud, and then they can run the software online. They don't need to install anything, zero footprint, and everything's already contained on the server, the terrain data, the clutter data, everything. And they just start right away with using the software for whatever need they need to accomplish. So that helps a lot with the training and ramp up time. And it's cross-platform compatible, as you can see, running off the cloud version or even the local version. It can connect through any device. So it can be a tactile device, a mobile device, PC, Mac, friendly with all of it. The third option here is what we call hybrid cloud, and this is probably most relevant to the subject that we're going to focus on today, which is the application programming interface. So in this particular implementation, part of the system may reside on the cloud and part of it may reside locally. So it's kind of a mix of the two approaches that I highlighted previously, local and cloud. So here you can see in the diagram, part of the system runs maybe off a person's laptop or some sort of a local setup that's not connected to our cloud, but then part of the system may connect through web service calls to our cloud and may be calling, let's say, our API for retrieving a particular result. This is a very common approach with some system integrators where they may develop their own platform and they simply need to use certain functions of our system. And they do it maybe even on a subscription basis. They will purchase maybe 6 months or a year to make X amount of calls a month to our system, maybe coverages or interference calculations or path profiles, and then they'll retrieve those results in an open format. It can be a KMZ or it can be ASCII grid or what have you, and then they'll store those results in their environment and then display it inside of their graphical user interface that they will control. So all of the different implementation options are synchronized through our web portal. We have our web portal available on spectrum.center. So any customer of ours has access to that portal. They get credentials and they can download the latest security patches, updates, product enhancements that we make available for the web stack. So we're going to get into the application programming interface of the platform Spectrum-E. First, we'll start with a brief definition. We'll highlight some of the key strengths of the Spectrum-E API. We'll get into a little bit discussing the calculation engine of Spectrum-E. It's a component known as Runpropmod. Talk a little bit about the performance advantages, and then a little bit of the use case example that I mentioned earlier, the delivery in Brazil. So API definition. So the Spectrum-E application programming interface, or API, provides a graphical user interface which defines Spectrum-E functionality in a manner to facilitate interactions with external software systems. So the Spectrum-E API includes a library of the functionality included across all Spectrum-E modules. That includes the technical analysis, the licensing modules, remote monitoring, as well as guidance on how to make a function call or request, such as conventions used and data formats supported. Spectrum-E's API is compatible with representational state transfer web services, also known as RESTful web services. It provides an automated level of interoperability between computer systems that are within the same local area network or accessible online. The Spectrum-E API also allows a programmer to extend existing functionality in various ways, such as scripting batch operations, and I'll get into a little bit more detail what is meant by that. But as you can see here, you would have your users here on the left-hand side. They have access to the Spectrum-E API. This can be, have it in a cloud, so it can be someone's working online and accessing our cloud-hosted version of Spectrum-E, or it can be on their local host as well. The local host install has the GUI for the API, and there they can put together their call, and through a web service connection can connect either to our data center or their own, to execute some sort of a calculation or a computation or some sort of a function that's included with SpectrumE. So here's a block diagram of the SpectrumE web stack. So as you can see on the right, you have it's a typical multi-tiered web application architecture. So you have in the top, this is the presentation layer, which is a web browser. SpectrumE works with any HTML5 compatible web browser, which is most all web browsers today, as far as I know. I think the only one that is not HTML5 compatible is Internet Explorer, but I think Microsoft is really pushing into Internet Edge today, and Internet Edge is HTML5 compliant. So then you have the different business logic layers. So you have client-side scripting, and then the server-side scripting. The server-side scripting is usually for specific application features, whereas the client-side scripting assists with rendering, information, displays, animations, things like this. And then the third layer, you have a storage layer, which is where you have the database, the GIS data, the file server, things like this. In the case of measurement data is also where you would store the measurement data if you were interacting with a monitoring or measurement system. On the server-side layer, there is also a proprietary component known as Runpropmod, which I've highlighted here in this little red circle. So the core engine of SpectrumE is an executable component known as Runpropmod, and it basically contains the functions that we sell with the commercial application. And the API that we offer primarily calls the functions inside of Runpropmod. It does also call other functions that we've contained in the server-side scripting, but a lot of it is the reason customers pay us basically is to access a lot of the functions in Runpropmod. So these are propagation functions, these are frequency assignment functions, these can be business rules. We have over 300 business rules that are spectrum management specific for various fields in, like, let's say in license processing, and various other things that are included in the tool, interference calculations, etc. So we'll go over the API in a little bit, but wanted to highlight how Runpropmod works. So Runpropmod basically creates task orders. And it's a multi-threaded application. So if you can imagine multiple concurrent users making concurrent calls to the SpectrumE system, the ultimately calls are going to Runpropmod, and Runpropmod makes a corresponding task order, an XML task order for each call. And those task orders can then be distributed over whatever the computing resources are available. So it can be down to a processor core. So SpectrumE is very hyper-threading, multi-threading, hyper-threading friendly. And we're going to highlight that a little bit in the performance section. So if you've got a good hyper-threading capability in your processing, or if you can leverage multiple processing resources, that's very easy to do these days using like an Apache web server. You can leverage a good amount of processing capability with SpectrumE. It'll distribute the computations over your processing resources. And we're going to see that highlighted in the product demo, how fast heavy computations can be if you've got good processing resources. So some of the key strengths of the SpectrumE API are in the areas of functionality, flexibility, performance, and scalability. This is what we're going to try to highlight in the demonstration part of today's webinar. You can see here a screenshot of the API. So the functions are on the left, and each function, when the user clicks on any one of them, you get the input parameters, the expected results, the error codes. You basically get the definitions of the function. So here we have highlighted the get coverage function. So an interesting thing to describe here, you can make, so each individual operation in SpectrumE is broken up either into like individual functions that can be called or can be combined into one function. What I mean by that is when a user wants to create a coverage map for a radio object in this system, there's several steps. First, you have to create the radio object, then you have to calculate a distance, then you have to call a propagation model, etc. So those discrete functions are included in the API, and if the user wishes, they can call those discrete functions and string them together through their own scripting. Or there are some functions such as get coverage, which does everything all at once. So you don't have to call and script your own, but you have both options. And why I mention that is because there may be situations where we didn't create maybe a particular function that strings everything together, but through whatever scripting language you prefer, you can script the calls yourself. So if, let's say, you want to batch a get coverage function, you can script that yourself. We're going to highlight that in the demonstration. So if you're missing a particular capability, you can always, if you understand the API well enough, you can string the functions together to get ultimately what you need. And that's what we believe is part of the strengths of the API, is the flexibility of being able to make use of the API in different ways, where maybe we didn't anticipate a particular type of operation that a user wishes to accomplish, but they can accomplish that on their own, just using a lot of the pre-existing functionality that's already developed into the API. And the Spectrum-E API also includes a call builder. It was at the sort of the top of that page that I showed previously. And this is just a bunch of options on how to create API calls. So we've got examples using key value pairs, JSON arrays, get calls, PHP curl examples. And the calls can be created in several ways. So, you can always have a custom scripting where you kind of string together several different function calls. You can use our call builder here, and we'll highlight how that works in the demo. And the software will create the call for you. You enter in the input parameters for a particular function, and the call will be created, and then you can make the call that way. And there's also tools to use. There's very common ones such as Postman and others that help make calls. So if you don't know that, it's not very difficult to learn. But this is a little more IT oriented, and results can be returned in a variety of formats, including but not limited to the following. There's a JSON array output, there's KMZ, KML, grid ASCII, text, CSV, shape. So Spectrum is very friendly at exporting results into open formats. So here's a little bit of an example on the performance. So we have a path loss calculation for 6,000 links that were run on two environments. One is our cloud environment. Here's the server specifications used on the cloud. As you can see, it's a 32 hyper-threaded system, AMD Ryzen processor, 16 cores, liquid cooled, 32 gigabytes RAM. And then we have a local environment. It's just a laptop, common laptop, Intel i7 processor, 2 cores, 4 cores hyper-threaded, 16 gigabytes RAM. And here we have some examples of how the output is, when the multi-threading is turned on and off in both environments. And as you can see, for the same operation, as you can increase the computing resources, you can dramatically reduce computation times. So, and we're going to go over this specific example in the demo. We're obviously not going to wait 15 minutes for the calculation to complete. We're only going to focus on the cloud-hosted approach, but rest be sure that if you remove computing resources, the computations will go slower. And it's for the reasons that I described above. There's less computing resources to distribute the computation demand. And as I said before, hyper-threading Spectrum is very hyper-threading friendly. I think today AMD seems to be the strongest manufacturer of hyper-threading processors. But I think both the main manufacturers, Intel and AMD, both offer processors for this that offer hyper-threading. Here's the use case that we're going to highlight. I will see, I'm not sure if I can demonstrate it today because this is a delivery that was done on site, on premise at a customer's data center in Brazil. So their data center kind of goes on and off sometimes because they host it themselves. So I was checking it earlier this morning and it was kind of offline. This is the URL. It's usually online, but in the case that it's not, anyone can later on, maybe today or tomorrow, if you click on the link that's in the handout on this particular page of the PowerPoint, this particular slide, I should say, slide 18, you can maybe test it yourself later. But what the customer wanted to accomplish was because there's the Telecommunications Authority, they're obligated to verify the cellular coverage footprint of all the operators in Brazil. This is Anatel, the Brazilian regulatory authority. And so what we did as part of our delivery, part of our contract delivery to Anatel, is we implemented a customized version of Spectrum. As you can see, they renamed it, rebranded it, they call it Mosaico. And it's hosted by them. And what they wanted to be able to do is have a system that communicates to the public the service level offered by every operator at any part of the Brazilian territory. So we're talking millions of BTS sectors, having to run a coverage simulation for millions of BTS sectors, considering 2G, 3G, 4G. At some point, they're going to want to grow that to 5G. And using their own GIS. They wanted to use OpenStreetMaps. So those of you familiar with Spectrum, you know that we have our own GIS map interface. We don't use OpenStreetMaps, but they preferred OpenStreetMaps. So it was very kind of customized delivery in that sense. They update these large coverage layers a few times a week. So using maybe kind of legacy tools, older tools, as you can imagine, trying to run coverages for millions of BTS sectors would take days, if not several days, maybe weeks to accomplish. So wanting to accomplish this, let's say 3 times a week, the system has to be able to really scale up very well. And that is something that was achievable with Spectrum. So what basically happens is they update their coverage footprint on their servers for every operator, for every service layer. And when the user logs into the system, they click on the map and it tells them at any position on the map, at any part of Brazil, what's the level of service for each operator. So as you can see here, you've got 2G, 3G, 4G, you've got the list of operators on the left-hand side. And it tells very quickly, instantaneously, what's the signal level. If it's good quality, it'd be in the greens, like 3 or 4 bars, I guess, or 4 or 5 bars. And anything less than that, it's going to go into yellow or red. I think anything less than 2 bars is marked as a red, obviously low service. If it doesn't detect a particular service, it'll leave it in blank. So you can see in the Nextel example, they only have 3G in that particular area where clicked on. So I don't know if it's working today. I feel, I don't want to try and venture into it. It wasn't working in the morning, but feel free if you want to later, click on the link in the handout and you can kind of test around. It's pretty user-friendly. Don't need to know anything in particular, knowing how to use it. It just works like Google Maps. You just click around and move the push pin around, and you'll get an update of this little readout that'll tell you the signal strength. So that's an example of where our API was used. Basically, the customer asked us to create a new GUI for them the way they wished, or it could have been something that they could have made as well. And then we just call the pre-existing functionality that's included in Spectrum. So in this way, Spectrum, its calculation component, Runpropmod, is used as a component under a separate hood, if you can imagine. Demonstration agenda. So for the demonstration, which will begin shortly, we're going to do 3 examples. The first example will be a single station coverage using an external test harness. So this is going to be a web GUI integrated with Google Maps, similar to the example that we had talked about just now in Brazil. So it's going to be a separate web GUI that is not Spectrum-y, that we just as a testing harness we developed with a little form where a user can enter in input parameters, and we're going to show how the API is working under this external test harness. Then we're going to show an example of stringing multiple API calls via a script. So it'd be like a batch station coverage using the Postman test environment. And then we're going to use, we're going to go to a third example, which is a single API call to a batch function. So instead of scripting a batch operation, it'll be a single call to a batch function. This is the path loss, the batch path loss function for the 6,000 microwave links. So that'll be kind of the more optimal way to do things. Obviously, things go a little quicker if you only have to make one call as opposed to 6,000 calls or several calls. But we'll show the both examples. So I think we're okay with that. We can start with the demo. I'm going to go ahead and make sure Ross is